Dear friends, welcome to Fusion Talk, organized by Beacon Impact Investment Fund. This is the second episode. In the first episode, we had 3 panelists, including 1 investor, 1 CEO, and 1 executive of research organizations. And in this second episode, we followed the same pattern. We are very honored to have invited Aaron Fyke as the investor and co-founder of a public company called Energy Vault, $1 billion market cap company. We also are very honored to have Eli Leland, the CTO of software companies that measures the performance of battery-based energy storage. We also have Dr. Yang from Cheng Daxue, whose research area that covers from smart grid to energy storage. All the energies has 4 pillars: generations, storage, distribution, and consumption. As we know, most of the green energies generations are not reliable nor consistent. Therefore, we do need to have a very efficient storage solutions to smooth out the peak and the valley of energy consumptions and generations. And then secondly, we will need to have the very efficient, smart grid to intelligently distribute the energy to where it will be consumed. So we are very pleased to have these 3 distinguished panelists to share with us their experience and wisdom. So we hope, under our moderator, Lawrence Yan, we will be able to have a very productive and informative discussion in the next 1 hour or so. Larry, please take the floor.
Thank you, CK. Good morning, everyone. I'm Lawrence, your moderator for today's event. And thank you, CK, for having me for the second time as the moderator of Fusion Talk. So like CK mentioned, on our first talk, we got a 50-year VC to talk about deep tech innovation from the US, as well as direct capture technology from Heirloom. Also, we had Dr. Alex Peng to talk about Taiwan's net zero strategy. So if you're interested in these topics, please get in touch with Be Current, and they have the link to YouTube available. And now, before I introduce the panelist, as CK mentioned, our core subject of today's meeting is energy storage. There are 2 very popular misconceptions. The first one is that in order to go carbon zero, we will need to install as many solar panels and build as many wind farms as possible. And second, renewable energy is more expensive than coal and fossil fuel energy. Neither are true. Sun and wind actually gives us more than enough energy to power towns, cities, and metropolitans. But the reason why we are still dependent on coal and fossil fuel energy is because we cannot store all of the energy that the sun and the wind provides. Much of it goes wasted. On the price side of things, let's take the US Southwest power pool, the wind belt, as an example, which is Texas, Oklahoma, Kansas, for example. On the wind belt, the 25th percentile of the electricity prices on the grid is about $1.25 1.25 cents per kilowatt hour. The 10th percentile is about 0.3 cents per kilowatt hour, which is just about the same as fossil fuel for the 25th percentile and materially cheaper than fossil fuel for the 10th percentile. But the problem is we cannot store enough energy during the off-peak hour to support the peak energy use. So energy storage doesn't just give our Teslas a longer charge, longer driving range, but it is also critical to maximizing renewable energy's contribution to the grid. So this is why I'm very, very excited to introduce to you today's panelists, 3 experts in the energy storage domain. For our first expert panelist, Mr. Aaron Fyke, is the founder of now Thin Line Capital. Before starting Thin Line Capital, Aaron worked very, very closely with Bill Gross's Idea Lab. Also helped Idea Labs, 2 of the Idea Labs companies, including Heliogen and Energy Vault, to go IPO in the US. Mm-hmm. Our second panelist, Dr. Eli Leland, is the co-founder and CTO of Voltaiq, the energy storage data and analytics company. And last but not least, our representative from Taiwan, Dr. Yang from Cheng University. Dr. Yang is a distinguished professor at the Department of Electrical Engineering and is an expert in Taiwan's smart grid development. So thank you for taking your time today. Without further ado, let's have our panelists first give us a quick introduction of themselves. First, Aaron, would you please kick us off and give us a quick introduction of yourself and Thin Line?
There we are, much better. Much appreciated. I've been looking at energy storage since working with the X Prize Foundation back in 2009. So at the time, and then I started a company called Energy Cache, which turned into a different company called Energy Vault, which eventually has gone public. And I feel that you're right. The opportunities that have been unlocked by the collapsing prices of renewable energy, wind and solar, will now have created this new opportunity, which is for energy storage, and it's somewhat of a double-pronged opportunity. Both the electricity grid and the transportation industry with electric vehicles will benefit from the collapsing prices of energy storage, and that's why I'm particularly excited. Thin Line Capital is a seed stage fund that invests in the decarbonization revolution, of which electric vehicles and renewable energy is a very important piece, which is, of course, how I came across Voltaiq and one of the companies in Thin Line's portfolio.
Thank you, Aaron. Just to add to that, Aaron also focuses on early startups. I think your ticket size goes from $300,000 US to 350. Is that correct?
Yeah, 300 to 500,000 seed stage companies, mostly data analytics and software. There's a huge opportunity now in what is considered clean energy of a number of supporting companies that are software based and or low capex solutions. So that's really the focus of Thin Line.
Great, thank you. Now to our second panelist, Eli, could you please give us a very quick introduction of yourself, of Voltaiq, what you guys do, and the problems you're trying to solve?
Absolutely. So thanks again for the invitation. Very honored to be included in today's agenda. So yes, my name's Eli Leland. My company is called Voltaiq. We are an enterprise battery intelligence company. So we aggregate data from across the battery life cycle, from R&D, product development, manufacturing, and the use phase, basically to optimize the impact of batteries on every part of an organization. So I'll talk a little bit of how we got started. So I have an engineering background, but I worked in enterprise software early in my career. Almost 20 years ago, I decided to pivot my career towards energy, dedicate myself to that. So I did a PhD at Berkeley in mechanical engineering, working on technologies related to electrification and smart grid. Coming out of my PhD, I joined an ARPA-E research grant. So it's the Department of Energy's advanced R&D projects function in a lab in New York City that was developing technologies, again, related to grid scale batteries and electrification, electric power conversion, stuff like that. And in doing so, we were in the lab building and iterating on many hundreds or thousands of new proprietary battery technologies and capacitor technologies. And the sort of short story is we built some very basic automation tools to help our work in the lab, help streamline data management and visualization and analysis. We found these tools gave us tremendous agility and the ability to drive forward our technology goals much, much faster through smart and efficient use of data and analysis. And it sort of seeded the idea for Voltaiq. So, you know, when we were starting, there were a couple things that we learned very directly firsthand. Number one, batteries are incredibly complicated. Everyone can relate to this. They behave unpredictably and fail unpredictably, as we all know with our cell phones. And also batteries are generating data across their entire life cycle. Almost every single battery doing anything of economic value is generating kind of a current and voltage heartbeat that's, you know, offering some insight as to how that battery's performing if you do that analysis. So even when we started the company 10 years ago, all of this data already existed. And then, you know, I think our unique insight was that batteries ultimately, in order to scale and achieve the potential that they have to affect a transition to clean energy in our society and totally transform things like transportation and the power grid and mobile communications, that really what was lacking was a true enterprise class data platform and infrastructure to gather up all of this data that was already existing across the life cycle, apply deep domain specific analysis to all this data, so that you can really understand, you know, what makes a good battery, what makes a bad battery, which ones are going to last and which ones are going to fail. You can almost think about our software as like, you know, if the current and voltage is like a heartbeat, then our software is like a cardiologist looking at an EKG of every battery that passes through our system. And so what we work with companies primarily in the transportation sector, consumer electronics sector, and the battery supply chain. So materials all the way through finished battery cells and battery packs. And ultimately, we're working to help our customers bring their products to market faster, for a high quality battery supply in a globally constrained market, accelerate the ramp up of manufacturing of batteries and optimize quality, and overall just minimize the risk, both physical risk and financial risk around batteries through smart data analysis. And in doing so, we created a sector that we call enterprise battery intelligence.
Thank you, Eli. Let me circle back to you later on to ask you about what you think about CATL's 1,000-mile battery. Thank you. So moving forward, our third panelist, Dr. Yang from Cheng University. Dr. Yang, could you please also give us a quick introduction of yourself, what you do, your research, and your part of the strategy in Taiwan's smart grid development?
Okay, yeah, thank you. I'm Hong-Tzer. I'm very happy to be here to join the discussion about the energy storage system and also the smart grid applications. Actually, our lab have over 40 team members focusing on the application of the energy storage system, and also we help the government and also the power industry to establish like the EMS system, like that means that the energy management system for the home, for the building, and also for the community. And also in terms of the microgrid and also virtual power plant, we also build up a platform for the power trading, and also to make the trading traceable, and also enhance its cybersecurity. We also build up a platform, blockchain, a trading platform. So in the blockchain trading platform, we divide it into two parts. One is the smart contract, and the other is the hybrid ledger. And also because we would like to have the EMS system to combine with the smart contract, we have a special design for the blockchain, and to have this building, matching, and also cleaning of the energy trading, and we also can dispatch the power and also the green energy through the smart contract. And also to make the power generation and also the power consumption traceable, we use the distributed hyperledger to have the user can access the data and also can do the accounting purpose through the blockchain platform. And also to control the distributed energy resources in the microgrid and also in the virtual power plant, we develop different control and management technologies to have the PV energy storage system and also the wind generation system to be controlled using our approach. The approach is that we control the real power and also the reactive power output from these distributed energy resources to make the frequency and also the voltage of the system balanced and keep the system reliable and also stable. And in addition to the current distributed energy resources, we also develop the EV charging station energy management system for Taiwan company. And the purpose is that we manage its charging speed, and also we do the V2G and the G2V control, and also integrated with another energy storage system with the charging station. The objective is that if we receive the signal from Taiwan, if one of the feeders that is have the problem of congestion, that means that there is not enough power to be transmitted or distributed to the charging station. We have to initiate the charging control, and we have a different business model to discuss with the Taiwan how to give the incentive to the CPO who participate in these programs. So we can have the EV driver and also the charging station and also the Taiwan to have mutual benefits to control the power enough for everyone. So these are the technologies and also the models. We have the government, we have the industry from the ESS, from the smart grid energy management system. Yeah, thank you.
Thank you, Dr. Yang. Okay, so thank you for your introductions. Moving ahead to our first topic in this discussion. So in our panel, Aaron, very experienced energy storage expert and investor, Eli, and software specialist. Everyone knows that energy and storage is such a capital-intensive investment with enormous amount of capital required to be deployed. But I think what's interesting is that software actually plays a very important role in energy storage. So our first discussion topic I would like to bring forward is software in the future of energy storage and smart grid. Okay, and first let's go to Aaron. You have had extensive experience in the energy storage and generation sector, from Heliogen to Energy Vault, from photovoltaic applications to gravity storage. Thinline focuses on a pre-A stage capital light startup, which is very different than what you've seen in Heliogen and Energy Vault. Could you share with us some of the interesting innovations around climate and energy intelligence and other software applications you see in your investment?
So that's a really broad question, but there's a lot of really exciting things that are happening, and your comment about software is a really good one. It's funny. I want to mention a couple of things which I think are important to realize is that independent of renewable energy storage makes the grid more capital efficient. I mean, you said that these are capital intensive investments, which I don't know if that's true in this, at least not with the stigma applied to that statement. They're no more capital intensive than building out a wind farm is capital intensive. And but what's interesting, when I started up Energy Cache in 2009, I looked at a lot of historic data, mostly in North America, from the ESA, the Energy Storage Association. And if you look at the difference between average power consumption and peak power consumption, that spread on the demand side, nothing to do with production, nothing to do with renewables, nothing to do with generation, just simply on the demand side, that spread has been continually increasing, which means the from a capital efficiency point of view, the grid is getting less and less efficient. You have to build out for peak demand, but the average energy consumption is average demand. So what energy storage allows you to do, energy storage allows you to build out for average demand rather than peak demand. And that difference, those savings is getting greater and greater every year. And that's completely independent from renewable energy. That's just demand side volatility. In fact, demand side volatility is so important, you know, and it's funny because now, you know, electricity grid investments are, well, turn the clock back to the 1960s and people just built stuff. And so there's a large pumped hydro facility. It's 1.2 gigawatts. It's 3 400 megawatt turbines. It's in California, called Helms. It's a pumped hydro facility. And the reason that a 1.2 gigawatt storage facility was built in California in the 1960s had nothing to do with renewables. It was because they had just recently commissioned Diablo Canyon, a nuclear power plant. And people say, oh, nuclear power plants are great because they're base load. But the truth is, nobody wants base load. What you actually want is something that's called dispatchable. You want to be able to ramp up and down your generation to match that of your load. Natural gas peaker plants are dispatchable. You can ramp, and they're used for grid balancing. So because they built this huge nuclear power plant, which basically could not ramp up, ramp down, or turn off, they needed to build a 1.2 gigawatt pumped hydro facility to manage demand side volatility. And so now with a whole bunch of renewables coming on, you have a whole lot of supply side volatility. But the truth is, for storage, this is not, you know, sometimes this is presented as a failing of renewables. Well, you have to put in wind and solar, but now you have to buy all the storage. But it's no different than the story that has been the case since nuclear power plants have been built, because now we have both demand side volatility and supply side volatility. And so on one hand, you install a bunch of storage, and pumped hydro has been great, but hydroelectricity is, at least in North America, pretty much fully exploited. There are no places left to build hydroelectric dams. And that's basically the situation in Europe as well. And there is some activity still happening in Asia, but you know, all the obvious hydroelectric dam sites tend to have been created. But what's really neat, and this is to your point about software, is that there's a lot of potential, which isn't energy storage at all, but demand response, basically shaping the demand side to match that of the supply availability. So software products that allow you to control remotely a fleet of electric vehicles so that you charge those electric vehicles to match the generation that's available. You don't charge them instantly. So we have been living historically since Edison's, you know, first part of the grid, in that demand is available whenever you want it. But the truth is, if we can shift demand, so there are loads, and we do this to some extent with appliances, washing dishes or clothes late at night or something like that. But I think there's a whole lot of opportunity to provide virtual storage through intelligent managing of load. And that's a big software problem. So that's one aspect of software, and that's not even anything that what Eli is doing, which is, I'll let him talk about it, which is a totally different software use case to handle the fact that electrochemical energy storage has its own characteristics. There's there's gravity storage, which is pumped hydroelectricity, and then there's a small variant, which are the companies that I got involved with. But they both basically, they're mechanical storage devices by lifting and lowering weights. There's thermal energy storage, and there's kinetic energy storage in flywheels, which can not store a lot of energy, but can ramp up and down quickly. They have a very high power capacity. But electrochemical energy storage has its own wrinkles of how you manage those devices. That's a totally different software application. So those are some of the things that I think are really interesting. But I do want to dispel this myth that it's because of renewable we need a lot of storage. No, storage makes, otherwise you'd have to build out, imagine if you had to build every road 6 lanes wide because one day there might be a lot of cars on it. I mean, it's incredibly inefficient, and storage allows us to manage and build out the grid far more effectively than it currently is, which is literally like building that multi-lane highway. And therefore I feel storage is incredibly capital efficient, not inefficient. But anyway, that's my take on it.
Thank you. That's super interesting because we always talk about food waste, how everything's lost on the road. I think similar to energy, most of the energy we generate is lost along the way. So how to optimize that is super important. Thank you, Aaron. So yeah, Leland, I would love to hear your perspective on energy storage. We talked about batteries and storage systems that they're getting more and more complex. Whether it is smarter grids, longer miles, or more mass market. What role does Voltaiq play? And how do you support your customers in ongoing research, in breakthrough technologies? Please share. I would love to hear more about Voltaiq.
Yeah, sure thing. So I think just to put Voltaiq and our software offering in the broader context of software around energy storage, I think even when, again, we started the company a little over 10 years ago in 2012, and already there was a lot of very interesting work and entrepreneurial activity around software to manage batteries, to do things like integrating them with grid assets and making it all run seamlessly and smoothly, optimizing the revenue side of batteries. But what we saw was that there was no one was really taking a close look at adding, at providing value about the actual physical battery itself and what it's made of and how healthy it is and what you can use it for and those sorts of things. What we saw was, I'll back up a little bit. So basically, anytime you're developing a new battery technology, say it's a new chemistry or a new anode or cathode or some additive that goes inside of the battery, or a new processing method for battery manufacture, or selecting a battery and engineering it into a mobile electronic device, or building it up into a much more complicated pack for use in transportation or on the grid. Fundamentally, in order to do that right, at present, and we believe that it will, it'll be this way for a long time, you really have to test a lot of batteries. You need to put them through their paces and test them you need to basically simulate the entire operating envelope of that technology in its eventual application. And you need to do it, repeatedly. You need to do it on enough batteries that you get a statistically significant result. And so that was one of the things that, inspired us to start Voltaiq, because we saw a lot of very similar types of work happening across the entire battery life cycle. So when I talk about battery testing, the kinds of things you're doing are, ultimately, you're charging and discharging batteries under very carefully controlled conditions in order to kind of map out the entire performance space of the intended application of that battery. So you'll charge and discharge it many, many times until its performance degrades. You can get an idea of how long it'll last, whether it's in mobile electronics on the grid or in transportation. You'll charge and discharge it fast and discharge it slow. You'll you'll put it through kind of like a pulsing cycle that simulates driving around in a vehicle. And you'll run all these things at different temperatures, and you'll run it over, sometimes months or even years to simulate the full application life of that battery. And anytime you're developing a battery product, you're doing this literally thousands of times on many, many, many different batteries. So all of that generates a tremendous amount of data. Again, it's these time series charge and discharge current and voltage curves. And so the practice of, battery science and battery engineering is largely about interpreting the data that comes out of those. Now, prior to Voltaiq, what we saw across all these different applications, different chemistries, different life cycle stages from early R&D all the way through product development and manufacturing, is that every organization had this battery data problem, and most of them were solving it very inefficiently, basically by making their engineers work harder and spend more time, writing spreadsheet analyses to process data from thousands and thousands of batteries. And to us, that's just sort of screamed out for an automation solution. So what our platform does is for all these batteries that are generating this this data signal, our platform automatically collects all of that data into a single platform. We convert it into a common format, so you can kind of do relevant comparisons across different generations of technologies or different chemistries. And then we provide a cloud-based software platform that takes all of this process data and makes it available to some end user applications that we've developed that help accelerate certain parts of the battery engineering life cycle. So again, when you're taking all that data, charging, discharging the battery many times under lots of different conditions, ultimately you want to boil all that data down to a couple key statistics about that battery that tells you what's its energy density. So how long will it last in a cell phone, or how far can you drive a car down the road with it? What's its power density? How fast can that car accelerate? Or if you're, braking an electric vehicle, how fast can you put into the battery? How does it perform across different temperatures? You want to boil it down to a handful, 6 or 7 key statistics: energy density, power density, fast charge performance, cycle life, which is how long it'll last if you charge it and discharge it a bunch of times, safety, cost. I'm probably forgetting one, but there's a handful of these statistics. So what our software does is basically provides tools to take all of this vast amounts of data and boil it down to those key statistics that you need to see about each battery in order to provide, comparison, choose which battery technology you want to introduce into your product line, in 6 months or 5 years from now. So that's kind of what our software does in a nutshell. In application, so some examples, we have customers that are doing early stage development of new battery technologies. So for example, it's slightly later stage startup. There's a company called Sila Nanotechnologies that's here in the Bay Area, and they are working to introduce silicon into the anode of lithium-ion batteries. So historically, it's been pretty much all graphite, which is just black carbon, and silicon can carry much more energy per unit volume, but it has inherent problems. It makes the battery swell and shrink a lot when you charge it and discharge it, and over time that causes mechanical breakdown and degradation of the inside of the battery. So trying to balance these different qualities. So a company like companies involved in R&D will basically be using our software. They'll be testing different iterations of their technology, evaluating their progress towards technology goals, using our software to collect all that data, take them right to the information that will allow them to make the decision about how to make the next iteration without having to spend many, many hours processing data in spreadsheets manually, basically. For companies, product OEMs, whether it's consumer electronics or electric vehicles, they are first and foremost, so they're doing some R&D work. They're working with those early stage companies. So Mercedes-Benz Research and Development Division in the US is a customer, and they use Voltaiq to track all of the different, they're sponsoring a number of different research projects, joint development, a number of different early stage technologies that they're monitoring for their future product roadmap. And they use Voltaiq to aggregate all the data from all of these different potential technologies that they might build into their cars in the future and benchmark them against one another in a very automated way. Moving a little bit further down the line, when you're actually getting ready to, you're going to build this product, whether it's a cell phone or a vehicle, you have to establish what supplier you want to use for your batteries. You need to find who is available to supply you those batteries. They supply you a couple sample batteries, you test them, you sort of down select and go from a number of potential suppliers down to one or two. And then once you've chosen your final battery, you have to do really deep characterization to make sure that you can operate it safely, to make sure that it'll last throughout the warranty, and to make sure that you can program the battery management system controller to operate the battery safely so that it'll last throughout its entire application life. So again, you're testing a ton of batteries, and all that data is coming into our platform. In manufacturing, it famously, can take, even for the biggest and most knowledgeable companies in the field, companies like Panasonic and LG, when they build a new lithium-ion battery factory, it takes them on the order of 4 to 5 years to get that factory up to full production. And in the process, a lot of cash gets burned up waiting for your yield, the percentage of batteries that come off your production line, to be high enough and your throughput to be fast enough that you can actually make money back on that investment. So again, at the very end of battery manufacturing, every lithium-ion battery goes through what's called formation, which is you charge and discharge the battery a couple times under very carefully controlled conditions to kind of lock in the internal structure. But we see a very large opportunity for taking that data, applying the deep types of analytics that Voltaiq does, and using that to do fast cycle iteration to improve the quality, yield, and throughput of new battery factories. So all of this basically just comes down to batteries are producing this charge and discharge signal, and if you have the right tools and infrastructure, you can create a lot of business value from that data that ultimately is aligned with our mission of helping to drive forward the transition to clean and sustainable energy, which we believe will be largely centered around batteries.
Thank you, Eli. Boy, I have so many questions for you, but I may have to cut in line in the Q&A session. But before that, thank you for that. Let's move forward to Dr. Yang. So, Dr. Yang, please, we understand that you are really a part of Taiwan's grid strategy. Could you please share with us, what is Taiwan's strategy in the development of the energy storage, smart grid, and some of the technologies that you see that Taiwan has supported or innovated?
Yeah, okay. Yeah, I'm very happy to hear what Eli said. We will have a reliable and discharging very fast battery in the future. But in the current applications of the battery, what we worry about is the data we obtain from the battery, like the SOC and like the SOH. Can we trust the data? Because when we submit the bidding for the ancillary services in the power market, what we worry about is the reliability of the battery systems. So this is my comments on Eli's talk just now. So about the Taiwan's strategies in development of the energy storage and smart grid, we can say that in last year, Taipower have opened the market of the ancillary services. For the ancillary services market, that can be divided into two parts. One is the before the meter, that means the automatic frequency control market. And people can submit their bids before 1 day ahead. And when we go to the day you have to follow the frequency signal to discharge or charge your battery. So up to now, the before the meter market, people who participate in it, about 13 megawatt. So the target is about 1 giga to gigawatt in the future up to 2050. But currently the price is still very sweet. So the people participating in this ancillary service, they get the money. But when more and more people go into the market, the price will be determined by bidding. So there will be a very competitive market in the future. So in addition to the before the meter market, the other one, the other application of the energy storage system is the after the meter. That include the reserve capacity, like the real-time and also the emergency reserve capacity. That will be also operated by Taiwan company of the for the market operations. So in addition to the after the meter for the reserve capacity in the market, we can also use the battery in the contract capacity regulations. And also in the future, because of the big power consumer regulation rules, the Taiwan government asked the big power consumer to what is big power? That is above 5 megawatt contract capacity. They have to install about 10% green power. They can buy the green power, or they can install the PV or the wind turbine in their campus or in their factory. So if you don't have the green power to purchase, you can also buy the certificate of the green power, or instead you can also install the energy storage system to replace the quota you have to meet. So in addition to that, the strategy is on the new building roof. The government also defined that you have to install the PV system on your new building roof. And also, if you refurbish or you remodel your building, your roof, as you also install the PV system. So this is one of the applications and the structures that Taiwan would like to achieve. Another one is the PV integrated with the energy storage system, and we call it the PV and ESS integrated system. That is that when most of the PV generated right now, they sell the green power to Taipower and to have the FIT price. And right now the government encourage the PV system. They can install an additional energy storage system, and they can save the green power into the battery system during the peak hour. And that means that the daytime. And also you can discharge the power into the feeder in the evening. The purpose is that to make a maximum use of the feeder capacity, and the another objective is to reduce the peak power, the peak energy, and also the peak load during the evening. That means that the dark curve during the evening when the sun goes up. So this is one of the strategies the Taiwan government would like to achieve, and also to enhance the use of the energy storage system, and also to build up the smart grid, and to accommodate more and more green energy in the system. So so this kind of strategies where the people would like to participate, but the difficulty is that do we have so much capacity of the battery we can purchase and also install? So but when we have the capacity, so the market can support it. So this is the issues we have to discuss later. Yeah, thank you.
Thank you, Dr. Yang. Okay, so moving on to our next round of topics and discussions. I want to talk about traction, challenges, and partnership in the innovation of energy storage. So Aaron, let's go to you first. Thin Line Capital has invested into a bunch of software and data intelligence companies. How are you helping companies gain market traction? Because we know there are a bunch of things out there right now. What are the challenges they're facing? And what are some of the critical partnerships you can build for your portfolio?
So I, as part of my investment thesis with Thin Line Capital is to only invest in companies that fall within my area of expertise, and companies that that I can help. So, you know, I might see a lot of really interesting companies that might be doing some really interesting things for shaping the grid, but it's in an area that I, you know, can't contribute at all. So I wouldn't make an investment into that type of company. But what I look for are, at least particularly for my fund, there are larger funds, you know, Amazon and Breakthrough Energy Ventures have several $billion, you know, for each of them. So they are pursuing a different investment thesis. But for my fund, I look at some big trends that I see happening. So wind and solar will continue to become cheaper than fossil generation. The main source of fossil natural gas, most of the displaced coal generation has gone to natural gas, and the biggest use of natural gas in the future will be for turbines to provide grid balancing services. So that's the huge piece that's going to be replaced by energy storage. That's a major trend. Another major trend is the fact that electric vehicles will be cheaper than internal combustion engines. And had it not been for supply chain disruptions from the pandemic, we would probably those curves would cross within the next year or so. Now it's a bit uncertain because the entire vehicle supply chain has been disrupted. But I'm looking, I would love to invest, sure, I would have loved to have invested in Tesla. That would have been great. But that's not really my thesis, is to invest in a company and Tesla did what it had to do. It had to become a completely vertically integrated electric vehicle manufacturer. But what I liked about Voltaiq, and the reason I invested with them, is they're not trying to be a new electric car company. They're recognizing that and by the way, their focus isn't entirely on the automotive sector. There's a number of places where batteries are being adopted, but my thesis is most applicable to electric vehicles. Automotive manufacturing is going to need a core capability for electrification that it has never needed before. And a company that can play a supporting role to enable the EV revolution, that's super exciting. And yet that doesn't require anywhere near the commitment that it took to try to get Tesla off the ground. Another one of my companies called Kavala, it's basically Google Maps for the grid. It's sort of a similar thesis. It's a big data analytics and company, a data analytics play where they don't do any battery storage. They don't do any energy storage at all, but they look at the grid and they know where every wire is and where every substation is, and they are looking at different use cases of electric vehicle adoption or rooftop solar adoption. So then they can identify to their customers, who are the electricity utilities, saying, look, these are the places on the grid where you'll get the best economic return for investing in energy storage. So you've got Voltaiq providing a critical piece of quality assurance and manufacturing infrastructure for EV manufacturers. You've got Kavala providing data analytics, telling people where to put energy storage. And, so I'm not investing in the gold mine, I'm investing the map to the gold mine. That's really my thesis. And so if I invest in companies like that, and then work with them however I can, that I think is really exciting, because when you completely change the automotive industry, the electric, utility industry, and a whole bunch of other things which are going to change building materials and agriculture and a variety of other things for climate change, then even a small supporting role can be a massive opportunity. And so that's how I look at things.
Thank you, Aaron. Let's stick with you a little bit, because I love how everyone is so passionate about what they're doing. So we're actually cutting into our Q&A time. We do have one question in the Q&A section, so why don't we just combine the second round of discussion and Q&A together?
I was halfway through, Pierre, I was halfway through typing that answer for you, and then I was asked it. So that was the answer I was halfway through typing up.
Let me just quickly read it out. So Dr. Pierre Lin in the Q&A part said that, could each of you share your view on, key technologies and challenges across the energy storage industry in the next 10 to 15 years. So why don't have Aaron, quickly, a minute address it, and later on when Eli talk about our discussion topic, you could bring that into the topic as well, and also Dr. Yang. Let's just combine the second round and Q&A together. How's that? So Aaron, please.
Well, I mean, that's mostly it. So you look at what's happening, the decarbonization of the electricity grid, the fact that renewables will be cheaper than fossil generation. But then you look at all these other things, and there are things, Heliogen's whole thesis, which is slightly outside of what Inline invests in, but there are lots of places in the world where small islands, for example, the one thing renewables are cheap, they have no carbon. They're volatile. That's not so great, and they're not they're not efficient. Solar takes up a lot of space, which if you are the state of Arizona, that's not a problem. But if you're, a small island, that might be more of a challenge. And so there is a whole industry around hydrogen, which is interesting. Now, hydrogen from a round trip efficiency point of view is pretty terrible. An electrolyzer might be 50% efficient, a fuel cell might be 50% efficient. So you're now, round trip efficiency of 25%, which is appalling. Batteries are, mid 90s. However, if it's a game where you're trying to move an extraordinary amount of electricity from, say, Australia, where there's ample land and ample sun, and serving big parts of Southeast Asia, hydrogen, if the economics pencil out, then that's totally fine. And efficiency is in a fossil fuel game, you care about efficiency because the implication is that low efficiency engines pollute more or are more wasteful. But when you're in a zero emission economy where it's, then it doesn't matter what your efficiency is if the economics make sense. And so I haven't invested in any hydrogen infrastructure companies or anything doing with hydrogen, but that is a big piece. Battery storage or any kind of energy storage, this is what Energy Vault is doing. Energy Vault is, in terms of mass energy density efficiency, probably any kind of gravity storage system is terrible in terms of mass energy. How much does a hydroelectric dam weigh? It weighs a lot. You're not going to power your car with a hydroelectric dam. But if the metric is dollars per kilowatt hour, that's super exciting. So there's different niches for grid scale storage. But then, like I mentioned, electric vehicles will be cheaper than internal combustion engines. They would have been in the next year or so, barring the supply chain disruptions. And that's going to completely turn on its head that roughly 70 million vehicles a year that are made from internal combustion engines. And so these are broad categories that I am pretty excited about.
Awesome. So rolling along, so Eli, I think grouping together with that question of Dr. Lin, what are Voltaiq's milestones going forward? What do you want to do in terms of commercialization? And, in the next 10 to 15 years, what are the opportunities and challenges for you guys?
Wow, excellent question. So commercially, in terms of the stage that we are now, so we're post-revenue, we're between Series A and B in financing. We have somewhere between 35 and 40 customers, ranging from small startups up to some of the biggest companies, technology companies in the world. We're very proud to call Google, Amazon, Microsoft, and one other company in that tier our customers. So those are companies that have figured out how vital batteries are to their product success in terms of building mobile electronics and selling services through them. Companies like Apple and Tesla have created many in value on a battery powered product portfolio, and the high tech sector has gets it. I think the big frontier for us is broader penetration into the electric vehicle market. It's a very obvious fit. There are some cultural challenges in that the major legacy automakers we say that our number one competition is not invented here. So basically, every company that has already been working with batteries has already figured out some, in our view, very suboptimal solution to managing and analyzing all of this data and extracting value from it. But there can be a lot of territorial mindsets within some of these companies. So we're hoping that these legacy auto OEMs that are looking to pivot their entire businesses to electric vehicles will take a lesson from the most sophisticated technology companies in history that are our customers, and understand that that there's a better way to do it. I think in terms of challenges for us, it's really all about educating the market as to the value that can be extracted, and the truly transformational business value that can be derived from this data, and also the risks of not taking that data seriously, sort of the upside and the downside, if you will. And then like so many companies in our position, I think there's just going to be a massive talent shortage in the battery industry. I think if you look at, just to zoom out a little bit and talk about, to address Pierre's question a little bit more directly, in terms of the scaling of batteries and energy storage in our industrial society, like, it's already happening. The key technology has already been invented. It's basically the lithium-ion battery and all of its variety of chemistries. We don't have to wait for some massive step change breakthrough. We're really excited to see when solid-state batteries might achieve scale in the market, but we're not holding our breath. There's an awful lot of, there's many millions of vehicles and devices out there that can be powered with the technologies that are available today, and those technologies continue to improve. So Lawrence, you asked about CATL's 1,000-mile batteries. So they're basically across the entire industry. There continue to be very steady incremental improvements that over time are making this technology really viable and compelling. So we don't have to hold our breath and cross our fingers and wait for some major breakthrough. The breakthrough's already here. Now it's about understanding how to use that technology to build businesses and derive value and affect, a global transition to sustainable energy. But the number one problem there is going to be scaling up and finding enough people to engineer these systems and run these plants. And so that's another way that we help, by making the people who are engaged in this work that much more efficient with their time. We help to ease that sort of human capital crunch that we're seeing across the ecosystem.
That's awesome. That's great. Thank you, Eli. And lastly, Dr. Yang, I guess just a bunch of questions together too. For Taiwan Smart Grid to be effective and efficient, what are our challenges in the next 10 to 15 years?
Okay, I just mentioned a few. One of the biggest challenges for the development of smart grid and also the energy storage system in Taiwan is the electricity tariff. That means that the prices of electricity is too low. Unfortunately, yesterday the government raised up the electricity prices, but it's only limited to the larger power consumer. And for the rest of most of the power consumer, they still have a very low electricity price. So that means that if the electricity price is low, and also the difference of the peak and off-peak electricity price is not big enough, that we cannot provide enough incentive to the smart grid, and also to the demand response, and also for the use of the energy storage systems in the future. So another one is the affordability and also availability of the energy storage system. I'm very happy to hear Voltaiq will provide us with the safer and also cheaper. We hope so. We hope so. So if we can have this kind of battery system, but the availability is also very important, because in the future, in the coming years, 1 or 2 years, we will have a big amount of battery volume to purchase. So this is another issues we have to overcome, the affordability and also the availability. Another one is the market size. Yeah, because of for currently the government is only focused on the reserve capacity. That means that only less than 2 gigawatt hour of a battery system is needed in before 2050. Then in the future, we hope the energy market, like the a day ahead, 1 hour ahead, and also real-time power balance market will be open. So at that time, the energy storage system can be applied to the reserve capacity, not only, and also we can apply it to the energy regulation. So we would have a bigger market size for the battery. So we would have more manufacturer of the battery to go into the market. And another one is the partnership. As I mentioned, we would like to have the product like mentioned by Eli. We can have the safer energy storage system to be installed at the basement to incorporate it with the EV charging system, so people would not worry about the firing and also or even explosion of the battery system. So these are the challenges we have to face and would like to overcome in the future.
Thank you, Dr. Yang. So we're at unfortunately 11:01. We're 1 minute overrun. So please let me give all of our, I know we have questions on the line, but we will actually put on a QR code on the screen later on. To our audiences, if you have any more questions, please reach out to us at BCurrent through the QR code, and we could pass on the messages and get back to you. And for our panelists, thank you very much for today's discussion. Personally, I have a lot more questions for Aaron, for Eli. I would love to hear more about Tesla Semi, if that's ever gonna work, right? More questions for Dr. Yang. So please do in touch. We'll chat very, very soon. Thank you, CK, for organizing the event. Will, could we please have the QR code on the screen? Thank you very much. Thank you for joining us. Please scan our QR code, join our chat room. Any more questions, please share with us in the chat room, and we'll hope to get back to you on these questions. Thank you, Aaron. Thank you, Eli. Thank you, Dr. Yang. Thank you, CK.
Thank you for everyone.
Okay, thank you. Thank you, everyone.
It's a pleasure. Thank you.
Thank you. Bye-bye.
Bye.